We have covered the theoretical portion of criteria of congruence for triangles in our earlier video. So in this video, we are going to solve some problems related to SSS Congruence Criterion, that is side-side-side congruence criterion for two triangles. So in this question, the question says, examine whether the two triangles are congruent or not. If yes, write the congruence relation in symbolic form. So we have two triangles, triangle ABC and triangle PQR. Okay, triangle ABC and triangle PQR, and the sides are given. So we can clearly see here that AB, side AB is equal to side PR, and it's equal to 3.5 centimeter. Then we have side AC, that is equal to side QR, and that is equal to 5 centimeter. And then we have side BC and side PQ. These two sides are equal, and the length of these two sides is 7.1 centimeter. Okay, now we can clearly see here that the three sides of this triangle and the three sides of this triangle are actually equal with each other. Okay, this pair, that is AB and PR, are equal, and AC and QR are equal, and BC and PQ, this one pair of sides is equal. Therefore, it satisfies the side-side-side congruence criterion, and therefore triangle ABC is congruent to triangle RQP. Okay, we can say triangle ABC, we can say triangle ACB, we can say triangle BAC. Okay, we can say a triangle QRP, RQP, PQR. Okay, doesn't matter. Whatever the order of the vertices is in the triangle's name, it will not change the definition. Okay, the meaning of the triangle. Now, write the congruence relation in symbolic form. Okay, now you have established that yes, these two triangles are actually congruent. Therefore, now you have to write the congruence relation in symbolic form. So from here you can clearly see that AB is equal to PR and AC is equal to QR. AB is equal to PR and AC is equal to QR. Therefore, you can clearly see here R is common and here R is common. What does it tell us? It tells us that in both these cases A was common here on the right hand side, on the left hand side, and on the right hand side this R vertex is common. It means that R and A are actually corresponding vertices, and in this case also it tells us that from these two, that is from this 1 and 2, we can establish that A and R are corresponding vertices. Okay, therefore from this one we can say that actually P and B are corresponding vertices, and from this one Q and C are corresponding vertices. What does that mean? It means if we take this triangle, rotate it, okay, and try to put this triangle over this triangle. So this triangle, since is congruent to this triangle, therefore it will completely cover this particular triangle, and this vertex R will fall on A, this vertex P will fall on B, and this vertex Q will fall on C. From these three, we can say that the congruence relation is ABC, right? And write this order, RPQ. What does it tell? It tells us that R falls on A, P falls on B, Q falls on C when you try to take this triangle, rotate it, and just try to put this triangle over this one. Okay, so this is the congruence relationship. This is the congruence relationship. That is, A and R are corresponding vertices, B and P are corresponding vertices, and C and Q are corresponding vertices. It means that from this one we can say angle A is equal to angle R, angle A is equal to angle R, angle from this one we can say angle B is equal to angle P, angle B is equal to angle P, and from this one you can say that angle C is equal to angle Q, angle C is equal to angle Q, right? Write the congruence relation in symbolic form. That's what you have to tell. These information from here we can say that these were the corresponding vertices, these were the corresponding angles, this is the correspondence under which these two triangles are congruent, and these are corresponding sides. Okay, why corresponding sides? It means that when this triangle will cover this triangle, then AB, this PR will fall along AB, this QR will fall along AC, and this PQ will fall along BC. Therefore, they are corresponding sides. So, correspondence, relation, corresponding vertices, corresponding angles, and corresponding sides. In this problem, state the three pairs of equal parts in triangle ABD and triangle CBD. Right? State the three pairs of equal parts in triangle ABD and CBD. Okay. So from this one, this is a triangle ABD and this is triangle CBD. It shows that whenever this sign is or symbol is given to you, just think that okay, you have to conclude that these two sides are actually equal. And here also this 2 marks here and these 2 marks, it means that these two sides are equal. So AD is equal to CD, BC is equal to AB, this one, and this side is already common, right? You can imagine, you can think of this figure as something like this. So this is A, B, D, and this will be C, B, D. I've just separated these two triangles. My point is to show you that this side is actually common. That's what it's here. Okay. Now, so from this triangle and from this triangle, side AD is equal to side CD, side AB is equal to side BC or CB, anything, and this is common, right? Therefore side BD is equal to side BD, and you can put in bracket as common side. Why common side? Because when we separate these two triangles in this fashion, then BD and BD, these are two common sides which have been represented by a single line here, line segment here. Okay, so clearly from this one, these three are equal parts. These three pairs, AD, CD, AB, BC, and BD and BD, these three pairs are equal parts in triangle ABD and triangle CBD. Okay, these are three things that are equal. Is triangle ABD congruent to triangle CBD? Yes, of course, because from this one, from this triangle 1 and from triangle 2, we can see here it's satisfying side, side, side. That is SSS Congruence Criterion. Okay, does BD bisects the angle ABC? Give reasons. Okay, it's asking whether this line segment BD is bisecting this angle ABC. So Angle bisector means that it will divide an angle into two equal parts. Angle bisector. Suppose this is one angle, and if this is an angle bisector, then this angle 1 will be this equal to angle 2. Angle 1 will be equal to angle 2 if this is the angle bisector. And that's what it's asking here, whether this angle is equal to this angle or not. Because if these two angles will be equal, then BD will be the bisector. Okay. From this one, you can clearly see that what are the corresponding vertices. You will say that, hey, that's very simple. B is here, B is here, was common. D is here, D is here, that is D is common. Of course, these were the corresponding vertices and these were the corresponding vertices. And in this case, therefore, the third pair left is this one, A and C. Therefore, A and C will be the corresponding vertices, right? Now, it means angle A will be equal to angle C. Angle A will be equal to angle C. From this one, right, this angle will be equal to this angle, right? Because they are congruent triangles. Congruent triangles means what? The triangles have same size and shape. Same size and shape means that the corresponding sides will be equal, corresponding angles will be equal. That's what we discussed in this case. So this angle will be equal to this angle. And what is this angle? This angle is this one. What is this angle? This angle is this one, right? Therefore, angle ABD, angle ABD is equal to angle CBD. CBD. How? We discussed here. And the reason is these are corresponding angles. Corresponding angles. Right? Now, since angle ABD is equal to angle CBD, therefore, yes, BD will be the angle bisector of angle ABC. Is triangle ABD congruent to triangle ABC? Very simple. This one line, cut or line, whatever you want to say, and this one here. It means that what? Side AD is equal to side BC. Side BC. For your, once again. Okay, let me simplify it a little bit so that you do not get confused. It's talking about this triangle and this triangle. Okay, now you can clearly see that this one is actually the common side of this triangle and this triangle, right? AD is equal to BC, and this double mark tells you that AC, side AC, is equal to side BD, and this is common. Therefore, AB is equal to AB, that is common side, right? Therefore, from this one, side, 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 right? Three sides are equal of one triangle is equal to the other triangle. Side, side, side congruence criterion is being satisfied. Since side, side, side congruence criterion is being satisfied, therefore triangle ABD is congruent to triangle ABC.